All right, so this is the second part of section 4.1. We're still doing integrals, but now we're going to be looking at applications. All right, so what we're going to be doing today is we're going to have to actually solve for the c value. What you did last night was you just had to solve for the integral. You didn't worry about what c was, but now we're going to solve for the specific equation if we're given the derivative and a point. We're also going to be looking at the graph of f prime and graphing f of x. That's something that we've already done. And then we're going to look at some application and word problems with integration. Okay, so remember that dy dx means the derivative of y with respect to x. It also means the rate of change of y when x changes by 1 unit. So the first example says we're given that dy dx is 3x squared minus 1. And we're told that y passes through the point 2, 4. We want to find the specific equation for y. If we know what the derivative is, how do we find the original function? What do we do to this? Nope. Take the integral. This is the derivative. We want to know what the original was, right? Think about this, guys. You know the derivative. You want to know the original, so you would have to integrate. So y is going to be equal to the integral of this. See, this is telling me the derivative of y is equal to that, so y has to be whatever the integral is. So what do you get if you add 1 and divide? X cubed. What's the integral of y, of 1? X. So now we have y equals x cubed minus x plus c. What makes this kind of problem different is that now they're telling us the point that it passes through. See, there are infinitely many functions that have this derivative, but there's only one that has this derivative and passes through this point. So how do I know c? How can I find c if I know this point? Plug it in, right? So y is going to be 4, 2 cubed is 8, minus 2 plus c. That's 4 equals 6 plus c. And so what's c going to be? Negative 2. So that means my original function had to have been x cubed minus x minus 2. That's the only function that has this derivative and that passes through this point. Okay? So taking it one step beyond what we did yesterday. Example 2. We're given again dy dx is negative 1 over x squared. Y must pass through this point 1, 3. Find the equation for y. What do we do to dy dx? Take the integral. So y is going to equal the integral of, now what's a better way of writing this? Good. Negative x to the negative 2. So now I can integrate this to find y. So I'm going to add 1. That's going to give me x to the negative 1. And then I had to divide by negative 1. So that's going to make it positive. And so this is going to be my integral. If the derivative is this is what y has to equal. But I have to find c. I have to find the specific equation. So I'm going to plug in 3 for y. So I'm going to have this. So c is going to be 2. So now I know my specific equation has to be 1 over x plus 2. Any questions with that? All right. Now, example 3. This is when we're given the graph of f prime, and we want to think backwards. What was the original function? If this is a squared function, what would the original function have to be? Some type of a cubic function, right? To be more exact, though, we're going to have to look at this. From here to here, these f prime values are positive. So I know that f prime is positive from negative infinity to negative 2. What that tells me is if f prime is positive, that means f had to be increasing from negative infinity to negative 2. I know that f prime has negative values between negative 2 and positive 2. What does that tell me about f then? If I have negative values on the derivative, what had to be true of f? It had to not have negative values, but it had to be decreasing from negative 2 to 2. Then I can see, finally, right here again, what's true of those f prime values? All of those are positive from 2 to infinity. So therefore, f must be what again? Increasing. Then you have to see if that makes sense. Would it make sense for our function to go increase, decrease, increase? Yeah. What has to happen at negative 2 if it's going to go increase to decrease? At negative 2, if I go from increase to decrease, I have to have a max. Here we're going to go from decrease to increase, so we have to have a min. So at negative 2, I have to have a max. At positive 2, I have to have a min. I have to go increase, decrease, increase. Now my directions say to sketch two functions. So that's just telling me that my c value could change. So instead of having this function, I could also have this function. I still need a max at negative 2. I still need a min at positive 2. But now it could look like that. So those are two possibilities for functions that would have that derivative. All right, looking over here now. This is the graph of f prime. So these values are negative. So from negative infinity to 0, what would I know about the original function if these are negative? It had to be decreasing, right? Then I know I have a vertical asymptote at x equals 0, so I'm going to have one again on the original. From 0 to infinity, these values of f prime are all negative again. So my function has to still be what? Decreasing. I'm going to keep the vertical asymptote. My function has to be decreasing. So it can look like A or B. Which one is decreasing, A or B? B. So I could have this as my original function again. From 0 to infinity, my function had to be decreasing. Is that going to be A or B? A or B? Which one's decreasing? A or B? Which one's going down? A. So this could have been my original function. Now, I also could have had a different c value. Maybe c is negative. I could have had this. And I could have had this. That's still going to be decreasing and decreasing. You see what I mean? That's what we're looking for. It's just a basic shape. Depending on what that c is, it would shift up or down. All right, let's go over to the back. All right, so this problem says, given g double prime of x is 4x, g prime of 1 is 3, and g of 1 is 4, solve the differential equation. When we see a problem like this, it's asking us to solve for g of x with no c's. That means we have to find the c's. So we're trying to find the original function with no c's. Find out what c is. When we have the second derivative, if I integrate the second derivative, what is it going to give me? The first derivative. So what I'm going to do then to find the first derivative is I'm going to integrate the second derivative. What do we get if we add 1 and divide? 2x squared plus c. Good. That's what g prime of x is. But look at the other information they give us. Go to your second clue. G prime of 1 is 3. So wherever I have an x, I'm going to have to plug in a 1. And then they tell me what is g prime of 1. What did they tell us g prime of 1 is? No, g prime of 1 is 3. So then c has to be 1. So now I know g prime of x, I go back up here, has to be 2x squared plus 1. That's my g prime of x function. If I know g prime of x, what do I do to find g of x? If I know the derivative of g of x, how do I find g of x? This is the derivative, so what am I going to do? Integrate. So g of x then is going to be the integral of 2x squared plus 1. So I'm going to have to add 1 and divide. This is going to be an x plus c. That's my original function. But we're not allowed to have any c's. So I'm going to look at what information I'm given. This says when x is 1, g of 1 is 4. So I'm going to plug in 1 for x. But what is g of 1? What did they tell us g of 1 is? 4. So I have 4 equals 1 cubed is 1 times 2 is 2/3. Plus 1 would be 1 2/3. So now I can find c. I have to subtract 1 2/3. Well, 4 minus 1 is 3. 3 minus 2/3 is 1 1/3. Or I'm sorry, 2 1/3. So 2 1/3 is my c value, so therefore g of x is going to have to be, go back to what it was. It was 2/3 x cubed plus x plus, this could also be written as 7/3. So what we had to do there, when we're given that second derivative, we had to find the first derivative by integrating. We had to plug in the information to find out what c was. We had to integrate again to find the original function. We had to plug in for x and g of x to find out what c is. And then we had to rewrite that original function. Any questions? All right, last problem. This is an application problem over business. If you're going into business in college, you'll take a business calc class. You'll see things like this. The marginal profit for a company's shirt production is given as dpdx equals negative 0.05x plus 40. The maximum number of shirts the company can produce in a month is 1,000. The marginal profit is the rate of change of the profit as x changes by 1 unit. So this is the derivative of our profit function. This is the rate of change of our profit function. So if this is the rate of change of our profit function, how am I going to find the profit? If that's the derivative of it, what do? Find the integral, right? So P is going to be the integral of this derivative. So to find the integral, I'm going to have to add 1. 1 plus 1 is x squared. Then I have to divide. 0.05 divided by 2 is negative 0.025. The integral of 40 is 40x. So here's my integral. negative 0.025x squared plus 40x plus c. I need to know what c is. But if you think about it, you know a point. Think about this, guys. If x is 0, what would the profit be if we don't create anything? What's our profit going to be? 0. So when we plug in x, the profit is 0. So what's c going to be in this case? 0. So I don't really have to worry about this c. Here's my profit function. I'm going to write it one more time. This is the profit function. All right. Now it asks us, what is the profit when the maximum number of shirts is produced? So it's like this company, if they just do as many as they can make, if they make as many as they can produce 1,000. But is that the best thing to do? Not always, because you may not be able to sell them all, and then you're going to be left with a bunch of shirts you can't sell. So the profit, if they make the 1,000, we would just plug in 1,000. If I plug this into my calculator, I get 15,000. That's what their profit's going to be if they produce 1,000 shirts. That's pretty good. But in part C, it says how many shirts should be produced to maximize their profit. Does anyone remember how we do that? How do we find the maximum profit? Take the first derivative and set it equal to 0, right? But don't we already know the first derivative? That's what we were given, wasn't it? We were given that. So I have to just take that first derivative that I already know and set it equal to 0. So that's going to give me this. I'm going to get x equals 800. So even though they're capable of producing 800 shirts, it's not going to give them 1,000 shirts. Producing 1,000 isn't going to be as good as if they produce 800. How would I find out how much money they're going to make if they produce 800? Plug that in. If you plug that in, guys, you get 16,000. So they're going to make $16,000 more if this is per week, per month. That's per month is what it was. They're going to make $1,000 more per month if they produce 800 instead of producing 1,000. They don't want to produce as many as they're capable of producing. It's just like with anything, you know, if you, a car company, they can't just produce as many as they can because they're going to have a lot of cars sitting there that they can't sell because they produce too many. So that's going to be what's going to maximize it. All right, any questions? Okay, good job.